Welcome to this demo video, which is a part of our VideoCoin network K2 release. The feature that we're going to be talking about is WebRTC input. So WebRTC came out in about 2011, and in just 9 years, it has become the de facto standard for live streaming video on many types of devices, including browsers, IoT devices, and even smaller devices where these devices don't have enough capacity to stream either RTMP or RTSP. So in these cases, WebRTC works really well. And in fact, WebRTC overall has received a lot of praise for being open and open interfaces and open implementations of WebRTC being available. So we're really happy and excited to be providing support for WebRTC in our K2 release. And in this demo, we'll see how to use WebRTC using the VideoCoin Studio interface. Like always, everything that can be done on VideoCoin Studio can also be done using the VideoCoin API. We're not going to be covering that. We're going to be covering how to do standard WebRTC streaming from your browser using VideoCoin Studio interface. More details about how to use the API itself will be covered in a blog post. But let's jump right into it. In this demo, on my left, I have the VideoCoin Studio interface. I'm already logged in and landed on my stream interface. And to the right, there is the new block explorer, which has a brand new tab called workers. So we'll go over what these workers do while we start the demo, but I want to do a quick recap on what worker nodes do. So there's a more detailed video on what workers don't do and how they work in one of our other K2 related blog posts, but just a quick overview. Worker nodes are basically third-party workers on the VideoCoin network. These workers are software, usually running inside a Docker container, that wait for video workloads to be assigned to them. And when video workloads hit them, they process it and upload it back to the VideoCoin network so that a publisher who's published video content to get work done on, the video gets processed and sent back to the publisher. And all of these happens using the VideoCoin native blockchain. So, like I explained in our previous video, the way we have architected third-party workers for ourselves is very interesting because in most networks, if there are no third-party workers, work doesn't happen. And let's say if this work submitted, assume that in the blockchain there are no nodes doing the work, then work doesn't get done. But in our case, what we've done is we realized that as we bring on board third-party workers, and as we bring on more and more workers across the globe, we needed to have a little bit more flexibility on what to do when there is no workers, but there are publishers who want to get work done. So we got a worker node implementation where if there are no workers available on the VideoCoin network, the VideoCoin network automatically provisions a new worker, gets it onto the network, and then gets that worker to accept work and do that on the network. So that's what is being displayed on the right-hand side with 29 total workers. All of them are offline right now. Offline meaning these workers are waiting to get a job, but they're offline and they only come online if there are no other workers available on the network. As you know, we just launched third-party worker support for VideoCoin network on the K2 release, so there's literally no workers on the network apart from these offline workers that are waiting in a dormant state. So we'll see how that works in just a bit, but for WebRTC, it is as simple as, if you're familiar with the VideoCoin Studio interface, it's as simple as creating another stream. I'm going to call this WebRTC demo K2. I'll give it a stream name. And previously, we were selecting RTMP as an input format. Now, all you have to do is select WebRTC and select the output as HLS. So in this case, I'm just going to say copy so that the WebRTC that's coming in from this HD camera will just be copied and replicated out. So I'm going to click on create stream now, and bam. So you can now see that VideoCoin Studio now has my video inside the browser. This is using HTML5 WebRTC HTML5 implementation within the VideoCoin Studio, and you can see that you can now see the green screen. So when I was recording this video, I was using OBS and then chroma keying out the background. But now in VideoCoin Studio, you can see the green screen, and you can also select the camera here. Just because I'm on a Mac, you can see that there's a FaceTime HD camera that you can select, and you can also select the mic here. So like I have an internal microphone on this Mac, but I've also connected a snowball mic here. These round mics, but you can see that showing up here. So you can select whichever internal mic and external mic you need. I'm just going to select the blue snowball here too, and I'm going to start the stream and let's see what happens. So like in this case, stream is getting prepared, and you see like in the protocol events, a stream was requested and it's awaiting input, and once and you see now that the stream input is receiving, right? Like now other protocol events are getting created, like stream created, stream deposited, and the refund and escrow mechanisms are being created, and now an output event and output stream will be generated. So now it comes back to our worker problem, right? Like as we discussed at the beginning, there are no third-party workers available on the network. So how does work get done? So in this case, VideoCoin does what we call as an offline node. It brings it back up on demand whenever there is no third-party node workers available on the network. VideoCoin network automatically creates a new node and then brings it up on the network. So like when this work gets completed on the network, you'll start seeing nodes here operational. And all of these protocol transactions like input chunk added, refund allowed, input stream created, and all of these things are getting logged in the protocol log in our block explorer. And there you go. There's an output stream now available. I'll show you how this output stream looks. But you can now also see that there is a worker that has come up online, which wasn't there before. And the way this works is because there was new work published on the VideoCoin network and there were no third-party workers available, the network went and provisioned a new network, brought it onto the network, and made it accept the job, finish it, and the stream is now available here. So like what I'll do now is I'll show you this HLS stream on a standard player. A stream was requested because it's awaiting input. There you go. And you see now, so there's a small delay here because of the amount of time it took between us provisioning the network node and then the node coming up, work assigned, protocol events, and all of these things for it to finish. It took a while. So there's some latency here, and which is standard in any type of live video broadcasting. There's some latency. There you go. This is a real stream performed by a real worker on a real VideoCoin node. And I can now go and stop stream, and the stream will be available here. And one of the coolest things that we've done is, you saw right in front of your eyes, the worker that was busy switches to idle, which means that the worker are workers that are non-third-party workers on the VideoCoin network come up when there's work, finish the work, and then shut down because we want to make sure that third-party workers run by others who join on the network get enough work when there is work, and we trigger workers, but we also make sure that publishers are not left in the dark if there are no workers on the network, and if there's a workload, we bring it up and then finish the work. So this is something, again, you can just try right away. You can just create an account on VideoCoin Studio and try this demo for yourself. We're very excited about this as well, along with the third-party worker demo. There are a few other demos that we'll be recording and showing you, so stay tuned, and thank you so much for joining us.